here is the Unit 4 rational functions review for our test coming up. All right, so we're going to go over a couple problems. We've been working on rational functions. So we're going to use Desmos, we're going to use a calculator, we're going to write some functions as well. So let's start out with these word problems. Jesse can build a tree house in 5 days. Cameron can build the same tree house in 8 days. How long will it take them to build a tree house together? Write an equation to represent the situation and solve. There are different ways we can write this equation. How we have done it is you take one and put it over what they do together. I mean, what they do individually. So Jesse is 5 days. All right. And make sure this is in the same thing. So days and days. And it is. Cameron is in 8 days. So that's by himself. So plus 1 over. And then if you had a third person, we would do the same thing, 1 over what they do individually, but it stops at 2. And how long will it take them to build the tree house together? So we say equals and 1 over together. Well, that's what we're trying to find. So 1 over x. So we've written our equation. Now we need to solve it. And we've solved most of these in Desmos. So we're going to go throw this in Desmos. You can get a common denominator of all of them and then set the numerators equal. So here, if I go and change this to Desmos, all right, so let me share the other one right here. All right. And I put in the equation. Remember, put in one side of the equation. So 1 divided by 5 plus 1 divided by 8. When it says equals, and by the way, we're not seeing the graph of this pop up because there's no variables. So make sure you put y equals right here out in front. Okay. And then here, we're going to put 1 over x. So 1 divided by x. All right. And where they intersect, now if they intersect in multiple spots, because this is a word problem, we really just want to deal with the first quadrant. And we see this gray, sometimes we have to zoom out. All right, and we see it right here. And we just want that x value, 3.077. All right, so let's go back. All right, so here we go. So x equals 3.077. And since this is in days, this is going to be in days. And if they're working together, it should be less than both of these. All right. Okay, next one. Corbin can canoe at a rate of 5 miles an hour in still water. Corbin travels down a river 10 miles and then back upstream the same distance. If it takes Corbin 1.5 hours to travel down the stream and then 4 hours to canoe back up, how fast is the speed of the water? All right, so the canoeing problems, okay, or just water current problems. All right, think about if you're going down a river, you're going with the current. Okay, so we're actually going faster. All right, and remember, we do the time, or no, the distance over the time. All right. And if we're traveling 10 miles, so down a river, and then we're going to do 10 miles back. So we're doing the distance on top over the rate. Okay, well, he actually canoes 5 miles. Well, the rate of the actual current is what we're trying to find. We're going to call that R. And if we're going downstream, that's plus 5 or plus R, sorry. Okay, now the same distance as we're going upstream is 10. Every now and then they change that distance. So if they said 10 down and 2 up, that would be a 2 there, but it's the same distance, so it's 10. All right, now this time we take our speed, but we have to subtract the current because it's going against us. All right, and this equals the time. Well, the total time when I add 1.5 and 4 together is 5.5. All right. So again, it's going to be easier if we go to Desmos and solve this one. So let's go plug this in. All right, clear out what we had beforehand, and we'll say 10 divided by 5. Instead of R, I'm going to put X. All right, plus, all right, 10 divided by this time 5 minus X. Because it says equals, I'm going to press enter, and I'm just going to put Y equals 5.5. When you don't have a variable, you've got to put Y equals for it. Now I'm going to zoom out a little bit. There we go. Now I do have 2 intersections, but which one do I want? I only want the positive one. If you said positive, you're correct. So 2.611. All right. So let me go back. All right. So that means R equals 2.611. And so like this is miles per hour because we were talking about the distance was in miles and the time was in hours. So the current is running at 2.611 miles an hour. All right, number 3, moving right along. Together, Tommy, Carl, and Peter can paint a house in 5 hours. If Tommy can complete the job in 10 hours, it should say by himself, Carl can complete the job in 7 hours by himself. How long will it take Peter to complete the job by himself? All right, so this is kind of like number 1. All right, we put 1 over each person by themselves. So Tommy can do it in 10 hours plus 1 over. Carl can do it in 7. We don't know what Peter, so I'm going to put 1 over X. That's what I'm actually trying to find. Equals 1 over what they do together. Together, they can do it in 5 hours. All right, so now we need to solve for Peter. So here we go. Let's change, grab your Desmos, and go plug it in. You should be doing this with us as well as I do this, not just watching the video. So put one side in, press enter, put the other side. Now 1/5 doesn't have a variable, so I'll put y equals. All right. Let's see. Does this intersect at all? I actually made up. Did I make up? All right. And it must not be possible. Okay. So sometimes if they never cross, there's no solution. So Peter individually, because these never cross, and I can zoom in and I can see they never cross. I made up a bad problem, but it's a good point to make. If they never cross, then it's no solution. All right. So here, there is no time. Okay. There's no time that Peter can complete by himself for them to do it in 5 hours. All right. We're going to keep going on. Find the following of each of the rational functions. All right. Now, some of these things we can do by graphing and some of them we can do by factoring, or we can do both on some of them. I'm first going to factor. That's one of the first things you need to do. The biggest thing is looking for a GCF. You've got to decide this. All right. So 2, I can pull out a 2 and I've got x minus 2. All right, now, and I might not go in order here. First thing is horizontal asymptotes. You can look at the degree. Okay, let's look at the degree here. The degree on top is 1, the degree on bottom is 1. And so therefore, when it's the same, we divide these leading coefficients. 2 divided by 1 is 2. Now put y equals 2. All right. Vertical asymptotes. Vertical asymptotes and holes, points of discontinuity, come from the denominator. So set any denominator equal to 0. X plus 3 equal to 0. So when I subtract 3, I get x equals -3. Now, because this does not cancel, it's just a vertical asymptote at -3. All right. We don't have anything else in the denominator. And a hole is when it cancels. So I don't have anything that cancels. So I don't have any holes here. Now, as far as our range, it kind of goes along with the horizontal asymptotes and vertical asymptotes. Make sure you write x with vertical and y equals with horizontal. All right, the range deals with y. Basically, the range can't be 2. If I write in an interval notation, it'd be -infinity to 2, and then 2 to infinity. All right, here, -3, x can't be -3. All right, and I would write it -infinity to -3, and then -3 to infinity, like that. All right, now, if you want to go to the graph for it, we can graph this. All right, and even if you didn't know how to factor it, you can find most of these. It's the holes that are the issue. So 2x plus 4, put the numerator in parentheses, okay, and then divide. Otherwise, if you don't, you would have to highlight it and then hit divide. Otherwise, it won't look alike or look the same that's on your paper. All right, and when I zoom out, okay, let me just do my fingers like this. We can see that right here, we could think about putting a dotted line right here that the graph isn't going to touch at x equals -3 vertically. So that's our vertical asymptote. Horizontally, that means going across right here, it would be at 2, y equals 2. And we can actually type in x equals -3 and we see it, and then y equals 2. And you can always check your answer like this, okay? And you'll see that it doesn't cross. The only thing is the hole. Now, there wasn't a hole in here, and so I can't really check that, all right? And you notice our domain, our x value isn't ever going to cross -3, and our y value is never going to cross 2. All right, moving right along to our next one. Same thing. Now, if you want to look at your horizontal asymptotes first, okay, that is looking at the degree. When the degree is the same, divide the leading coefficient. So it's at y equals 1. All right, now let's go factor. You should recognize that as a perfect square. So x plus 4 and x minus 4. All right, you can use Desmos. If you actually graph x squared minus 16, a root will be negative 4. So the factor is x plus 4, think opposite. And another root would be positive 4, so it's x minus 4. All right, now we factor this. Factors of 20 that add to 9 are positive 4 and positive 5. Now, I know some of you are going to want to cancel it. Don't yet. All right, vertical asymptotes and points of discontinuity. Our holes come from setting the denominator equal to 0. Now, some of you may be able to think, okay, it's just the opposite. All right, here minus 4, so x equals negative 4. And then minus 5, x equals negative 5. Now, let's focus on the x plus 4 here. Okay, so this x equals negative 4, notice it cancels. So therefore, we have a hole at x equals negative 4. All right, so if it cancels, it's a hole. And then a vertical asymptote, because x plus 5 doesn't cancel, at x equals negative 5. All right, and now here we can look at our domain and range. If our horizontal asymptote is 1, that means y can't be 1, but it could be written as negative infinity to 1 and 1 to infinity. Now, for our domain, we look at both the hole and the vertical asymptote. So here, x can't be negative 4, and it can't be negative 5. So when I write it in interval notation, it's negative infinity to negative 5. Think about like what comes first from the left to the right. Okay, we're going to jump over negative 5 and go to negative 4, and then negative 4 to infinity. All right, and again, we can graph it. If we graph it, all right, so if I graph it, x squared, and make sure you know how, before going to your test, how to put these into the calculator. All right, if you like TI-84, great, use that. Right now, I'm just using this one right here. Okay, and if I zoom out, okay, I can see, and double check. All right, and if you want to, let me zoom in one more. All right, we had said we have a vertical asymptote at x equals negative 5, appears to be, and we said also y equals 1. All right, it appears to be that we can draw those lines. Now, the hole at x equals negative 4 is the tricky one. If you're just graphing this, you may miss it, all right, at negative 4, because if you're going too fast, you may not see it, all right? And here, if I go slow enough, I can see it at negative 4, x equals, it just takes, I just saw it. There you go. It's undefined and it looks like an open circle. Okay, if you go too fast and just eyeing it, you don't see the holes in the graph. You can get the asymptotes easily, but getting the holes is a little bit of a different story. All right, so this one right here. Okay, horizontal asymptotes. Let's look at the degree. All right, the degree up top is 1, the degree here is 2. So here, when the degree in the denominator is greater, then our horizontal asymptote is y equals 0. All right, we can go ahead and write our range. Y is not going to equal 0. All right, negative infinity to 0, and then 0 to infinity. All right, vertical asymptotes come from, we need to factor this at 3 factors out. All right, I know my GCFs. I know 3 goes into 3 and 6. All right, and then here, factors of negative 12 that add to negative 4 are negative 6 and positive 2. And then I'm going to put my x's in there. All right, and let's set them equal to 0. Okay, you may just be able to figure out x minus 6, that's x equals 6. All right, x plus 2, opposite is x equals negative 2. All right, and here, x minus 6 is my vertical asymptote because it does not cancel. All right, so x equals 6 is here. And then x equals negative 2 because the x plus 2's cancel is my hole. All right, and you can go graph that. You can find your hole and so forth. Now, as far as the domain, it can't be 6 and it can't be negative 2. So I would write it negative infinity to negative 2 comes first in the number line when you're going left to right. Then negative 2 to 6. And then 6 to infinity. We just jump over those two x values right there. Okay, so be able to find all those. All right. And they may not ask you to find all of it at once. They may just say, hey, find the horizontal asymptote here, find the vertical asymptote here. Okay, for the different problems. All right. Now, to solve rational equations, honestly, to solve rational equations, just go to your calculator. All right. And see them and state the solutions. So I'm going to go and I'm going to put these into Desmos right quick. Again, the biggest thing that you need to do is practice putting it into Desmos yourself and know how to put them in there. All right. So 2 divided by x minus 1. All right. When it says equal, press enter. Then it says 4 minus x divided by x minus 1. Find where they intersect. Now, these aren't word problems. So if there are two solutions, two intersection spots, then we want both of them. Here, there's only one. And all we want, now the x and y on this one's the same. All we want is the x value, okay, which is 2 in this one. All right. So when I go back, I'm just going to write x equals 2. Now, when we talk about extraneous solutions, okay, if there's an extraneous solution, you can look towards the denominator. Here, we know x can't be 1. Now, the graph isn't going to show us that. All right, it's just not 1. Yeah, 1. Because when I plug 1 in here, it makes those denominators 0, and we can't have a 0 in the denominator. All right, going back to 6. Now, I'll write this first. We know x, because this is a denominator, what's going to make that equal to 0? Just think about setting the denominator equals 0, x equals 0. All right. And that's what x can't be, because when I plug 0 in there, it's going to make that denominator 0. All right. Now here, let's go graph it. All right. We're going to have x plus 12 over x. And then enter. Now, because it says 8, I just want to put x equals 8. All right, so let's see this. All right, this time I notice I have two intersections. And remember what I told you the solutions were. It's the x values. So we got 2 and 6. All right, and you'll notice it's never going to be this number that I've written that x can't equal. So x equals 2, x equals 6. It's just if it asks you for extraneous solutions, those are going to come from the denominator, okay, and what x can't be. All right, so let's look right here. What can z not be? -2. And how I'm getting that is I'm setting z plus 2 equal to 0, and I subtract 2. So z equals -2. And again, some of you can just eye it. All right, so let's go plug this in. All right. Now, what if they never cross? So what's our answer? It should be no solution. All right. I don't know if this one's one of those, but let's check. Okay, so 9 over 28. All right, plus 3 over z, or actually don't put z, put x. All right, plus 2. All right, press enter, and we're going to put y equals 3/4. All right, and I see that it's intersecting right here. You can zoom out just to double check it's not intersecting here, and I don't think it ever does. All right, so again, it's our x value, so all we want is 5. All right, there's only one solution on this one. All right, so here x equals 5. All right, so be able to use your calculator there. That's kind of the best thing. All right, now simplify each of the following. Check your answers in Desmos. All right, when we're subtracting, okay, you've got to get a common denominator or a least common multiple. Right here, these look opposite. All right, when it looks opposite, I'd say something like -1 technique. Okay, so here what we can do is we're going to keep this one the same. And it doesn't matter which one you pull it out of. If I take a -1 out of this right here, so if I take a -1 out, it changes the x to positive and the 3 to negative. All right. And what happens is I can put x minus 3 here. The -1 can float top or bottom. So I can put it here on the 3 up top. And really what happens when we have a minus negative changes to a plus. Well, look at it. I'm now adding, and I do have a common denominator. So once you have a common denominator, just add these two together, and I get 11, like that. So here's our answer. Now, what I mean by check in Desmos, and I'm not going to check every single one of these, but you can to practice, is you take the original problem, 8 divided by x minus 3, okay, minus 3 divided by 3 minus x. And now put in your answer. Our answer was 11 over x minus 3. Well, what do you notice? If I take this blue off and I change it to red, you'll notice they're the same graph. Okay. Had I got 12, I knew this was wrong because I see two different graphs. They're not the same graph. All right. So you got to make sure the original problem and this one are the same. Now, when it comes down to multiple choice, you can do the same thing. If you don't know how to do it by hand, put in the original answer and put in all the answer choices. The answer choice with the same graph is going to be your answer. All right. So I'll let you check all these on your own. I'm just going to do them all by hand. All right. This one right here, I'm pretty sure that should, let's see. If you don't know how to factor this, actually, let's go to Desmos and factor. I wasn't going to go back, but let's go to Desmos and factor. If you don't know how to factor, so here we go. 2x to the third. All right. Minus 14x minus 12. All right. So go look at the roots. Oh, well, that's a nice one. -2. So what's a factor? X plus 2. So I'm going to go ahead and write that down. All right. This one is at -1. So what's a factor? X plus 1. And then this one is at 3. So x minus 3. Think opposite. So guess what? I factored it. All right. I'm done. All right. With the top part. Now, the bottom part. Now, if you're having troubles, I know it's 4x plus 4. Now, you'll see a -1. So since it's -1, it's going to be x plus 1 is a factor. However, when I go back to the problem, or you can see it right there, you see the 4s. Okay. Now, x plus 1 isn't the same thing as 4x plus 4. You have to recognize the GCF of 4 came out. All right. Now, when I go to simplify, these cancel. So our answer is x plus 2, x minus 3 over 4. Now, when we talk about domain here, and I should have talked about it here, here the domain, x can't equal, when I set the denominator equal to 0, x minus 3 equal to 0, and I solve, I get x equals 3. Okay, that means x can't be 3 or it makes that denominator 0. All right, so for this one right here, the domain, you have to look at it before you cancel it out. Since this said x plus 1, think opposite, -1. X can't be -1 because if I plug in -1, I'm going to get 0. All right, now moving along, factor this. Now the key is division. If it's division, all right, factors of 1 that add to -2 are -1 and -1. All right, x minus 5. I'm going to put parentheses around it. Now change it to multiplication. All right, and flip it. That's x plus 5, x minus 5. All right, and then the x minus 1. Remember, when it's multiplication or division, we keep this the same. We change this to multiplication and we flip that. All right. Anything that's the same in the numerator can cancel with the denominator. Now, only one of these can cancel. All right. And here, this cancels. Now, what am I left with? I'm just left with x minus 1 and x plus 5, and both of them are on top. Now, sometimes they do multiply these out. X times x is x squared. X times 5 is 5x. -1 times x is -x. And -1 times 5 is -5. So x squared plus 4x minus 5. Sometimes they'll leave it factored, and sometimes they'll multiply it back out. If it's an open response question, you can just leave it factored. All right, moving right along. Now, so we got some more of these up here. All right, number 11. Okay, factor it. Perfect square. X minus 1, x plus 1. All right, you should be getting good at it now. All right, if not, go throw it into Desmos. Factors of -10 that add to -3. All right, that is -5 and +2. Multiplication. All right, factors of 35 that add to -12 are x minus 5 and x minus 7. And here, factors of 2 that add to 3 are 1 and 2. So x plus 1, x plus 2. All right, as long as it's in the numerator, it can cancel with anything in the denominator. So x plus 1, x plus 1. All right, x minus 5, x minus 5. Now, these don't cancel because both of them are in the denominator. All right. Okay, so in the numerator, we have x minus 1, x minus 7. Here, because there's two of the same thing, you can write it out as x plus 2 squared. All right. Now, number 12. It's adding. We need a common denominator. Okay, now you can't just like add or subtract things. You can only multiply things to the denominator. So like this one needs an x plus 2, but whatever you do down low, you have to do up top. This one needs an x minus 1. All right, so here, now my suggestion is go ahead and distribute that numerator. So my common denominator is x plus 2, x minus 1. Now my numerator, 2 times x is 2x. 2 times 2 is 4. All right, plus 3x times x is 3x squared. 3x times negative 1 is negative 3x. All right, just to simplify the top, 3x squared. My x is 2x and negative 3x is negative x, and then plus 4. All right, and again, check these. Put the original into Desmos, put your answer into Desmos, and they have to be the same graph. All right, now this one right here. Now, sometimes you need to factor the denominator. All right, in this case, I do. I'll put parentheses around those right there. Okay, now what does each denominator need? Like this needs an x plus 2. So whatever I do down low, I do up top. Now this one now needs a 3 and an x minus 2. So make sure you do a 3 and an x minus 2. All right, so my new denominator is going to be 3, x plus 2, x minus 2. Now here, x times x is x squared. X times 2 is 2x. Now be careful. We've got this minus sign, and I apologize. There you go. Okay, we've got this minus sign right here. Okay, we can put this on the 3, the negative 3. Now, the negative 3 only gets distributed into one of these. So I'm going to have x plus 1 times negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. And now we can multiply out. X times negative 3x is negative 3x squared. X times 6 is 6x. 1 times negative 3 is negative 3x. And 1 times 6 is 6. All right, so here, my like terms, x squared and negative 3x squared is negative 2x squared. All right, my x's, 2x and 6x is 8x, minus 3x is 5x, and then my only constant is 6. And again, graph the original one and graph your solution to see if they're the same graph. All right, moving right along. Least common denominator, we just did that in 12 and 13. All right, and on one of the other problems beforehand, factor the denominator. So that's x minus 2, x minus 1. This is going to be x plus 1, x minus 1. All right, and just think, I got to get them to look alike. Well, this one needs an x plus 1. This one needs an x minus 2. So the least common denominator, just choose one of them now that they look alike. All right, simplify the expression. Now, if you can't factor this, we can use division. All right, now with this division, you're going to have to use long division. Now, I don't have a lot of room right here, so I'm going to grab a sticky note right quick, and I'm going to do it on a sticky note that's right beside this. All right, so we have to do this long division because it's x squared. All right, so 4x cubed minus 3x squared. Double check, x cubed, x squared, x, and then minus 3, constant. All right, so here we go. 4x cubed divided by x squared. All right, that gives us 4x. Now go multiply. 4x times x squared is 4x cubed. 4x times that is 4x. All right, and then here we're subtracting. So what we've got to do is change our signs. You got to distribute this minus sign throughout. All right, and now these cancel because one's positive and one's negative. And I forgot. Oh, wait, hold on. What problem are we having? Do you see that this is a minus 4x and I lined it up with x squared? I needed to line it up with x. All right. Now what happens is this drops down and is negative 3x squared. That's negative 3x minus 3. Okay. So make sure you're lining up your like terms when you do this. Sometimes you skip them. All right, now take negative 3x squared and divide it by x squared. All right, here the x's cancel and I'm left with negative 3. So negative 3 times that is negative 3x squared. Negative 3 times 1 is negative 3. So I'm lining it up with the correct one. All right. Now go change your signs because I got to distribute that minus sign. These cancel. These also cancel. Sometimes they won't. But what I am left with is the negative 3x. This is our remainder because if I try to do negative 3x divided by x squared, I'm going to have something left in the denominator. So I don't do anything else with that. For our remainder, we're going to put negative 3x and we're going to put it over what we're dividing by, x squared plus 1. All right, so that is the answer to number 15. All right, and at any time you need to pause or re-look at a problem, just or rewind and do it. Okay, which function could be this graph? All right, now one of the things you can look at is like horizontal asymptote. Right here, the horizontal asymptote is at y equals 4. We can also look at the vertical asymptote as well. The vertical asymptote is at x equals 1. All right. Now, when it's written in this form like this, when you have a whole number, okay, horizontal asymptote at 4, well, that number right there is our horizontal asymptote. Okay. And then here in the denominator is where the vertical asymptote is coming from. So if it's x equals 1, then it's going to be x minus 1. All right. So C is our answer. When in doubt, just go graph your answer choices. I'll just graph like 2 of these. So here, if I graph 1 plus x minus 1. Now, if I didn't put parentheses, you highlight it and then do division. All right, x minus 4. And I can tell that this is definitely not the same graph. All right, these should be kind of gimme problems because you're just plugging them in. All right, now if I actually put in the answer 4 and then what was that? Minus 2 and then minus 1. And I look at it, I see, hold on, oops, I messed up. Actually, you know what? None of these are the answer. If you actually look at it, this is why you do need to graph it. Do you see how it's opposite of what our graph is? All right, this is actually opposite. Our graph went like that. All right, so there's actually no answer to this right here. So sorry, C is not the answer. Always graph it to make sure. All right, and what's actually happened is it's, what am I thinking about? What's happened is it's like flip this over. So there's like been a negative somewhere. All right. So that's probably like a minus right there. All right. Now, number 17. A boat is traveling 20 miles at a speed of 50 miles per hour. The boat will have an average headwind of X miles per hour, which means it's going against the wind. The situation can be modeled by B of X. All right. Which is 20 over 50 minus X. What does B of 5 mean? Well, 5, that means we're plugging in 5 in for X. All right. So we get 20 over 45. If I were to reduce this, if you ever want a calculator to reduce a fraction for you, if you don't know how to do it, all right. If you do this alpha X like that, you're going to have this pop up and we're going to put 20 over 20 divided by 45 and press enter. It'll actually come up with the fraction for you, 4/9. Now go back to the problem, what this meant. X is the miles per hour. So here, 5 miles per. So when the boat is traveling 5 miles an hour, okay, the Y value is this, is the average headwind is 4/9 miles per hour is what that means. All right. And at what value of X does the graph have a vertical asymptote? Vertical asymptotes come from the denominator. And really, you can graph this to figure this out or set the denominator equal to 0. Subtract 50. And when I do that, I get negative 50. And then divide by -1. So X equals 50. All right. Or it's whatever value that you plug in there that's going to make the denominator 0. These don't cancel out. So it's not a whole, it's a vertical asymptote. All right. Moving right along. Identify the following from the graph. All right. Sometimes you're just going to be given graphs. Domain right here. Okay. Find your vertical asymptotes, and that's at negative, let's see, -2, -4. These are going by twos. -2, -4, -6. All right. So the vertical asymptote is at x equals -6. All right. My whole is at 2. X equals 2. And so these are our domain right here. Basically, x can't equal -6 and it can't equal 2. So negative infinity to -6, -6 to 2, and 2 to infinity. All right. Now, horizontal asymptotes. If you look right here, it looks like it's here at 0. So we're going to say y equals 0. So y is not going to be 0. All right. So negative infinity to 0 and 0 to infinity. All right, x-intercepts and y-intercepts. It appears the x-intercept, if you look, it never crosses, so we have none. The y-intercept, now this one's kind of hard to see, and without knowing it, we're just going to estimate it. It looks like it's at 1. All right, so we'll just put the x-intercept at 1. All right, so off the graph, sorry, it's kind of hard to read. All right, so let's go to this one right here. Same thing. All right, we can come up with our vertical asymptote. Here's our vertical asymptote is at x equals -2. It looks like our horizontal asymptote is here at 3, so y equals 3. And it looks like we have a hole at x equals -1. All right, so my domain's not going to equal -2 or -1. So negative infinity to -2, -2 to -1, and -1 to infinity. All right, and then for y's, it's not going to equal 3. So negative infinity to 3 and 3 to infinity. All right. Now, as far as x-intercept, it looks like it's crossing right here at 1. All right. There could be multiple, but in this case, there's only one. All right. And then here, y-intercept, we're just going to take a guess at it. We're just going to say it's -2. All right. So make sure you know all of this about rational functions, know about their graphs, know how to simplify, know how to factor. That's a big thing. If not, know how to do it in Desmos. All right. And hopefully you will be ready for your test. If you need to, rewatch this over again.